You guys have done functions before, but we're going to go back over them, and I'm going to talk to you about them. So in previous years, I haven't really kind of been able to get a good flow for functions, but this year I think it flows really good. So we just got done talking about bivariate data and about scatter plots. And scatter plots tell us how two things relate to each other, right? So it tells us about the relationship between two variables, okay? And we're going to be talking about relations and functions. So relations are any set of ordered pairs. So it might be a scatter plot, it may be a linear relationship, maybe something in the real world, maybe a family that we haven't even learned about yet, okay? But a relation, it says any set of ordered pairs is a relation here, okay? So here's what that means, okay? What that means is a relation is anything I can graph. So if I can graph it, it's a relation. So if you can graph it, it's a relation. Okay? So, like these graphs here, these are relations. This stuff on our homework, okay? This graph, this mapping diagram, this table, all of this, these are all relations. These, all of it. Anything that I can graph. So anything with an x and a y coordinate is a relation. All right, now, when we talk about functions, functions are special relations, okay? Functions are relations where, hold on, I gotta pause this. Sorry, internet, I gotta pause you for a second. All right, so if you can graph it, it's a relation, all right? Now, functions are special, is a special relation, okay? So a function is also something that I can graph, but none of the input values can be repeated. So that's a little confusing. That's kind of a confusing mathy sounding statement. So I'm going to show you with a vending machine what this means. Okay, the vending machine. Okay, so it's going to be a weird looking vending machine. Okay, so here's the vending machine. So here we're going to draw two big bubbles to represent our vending machine. Okay, so this is the buttons and this is what's happening inside the machine. Okay, and our vending machine is going to have 6 buttons. We're going to label them 1 through 6. 1, 2. Well, you better figure it out, girl. 3, 4, 5, 6. So there's my vending machine. You're like, that is the weirdest looking vending machine I've ever seen. But just go with it. Okay. Yeah. Y'all may have learned about it last year too. But again. Okay. So what should be in our? This is a Coke machine, right? So let's think about the Coke machine. What should be in our Coke machine? Probably Coke, huh? So the 1 button, if we push the 1 button, we're going to get Coke. Okay? What else should be in the vending machine? Pepsi. We can't have Pepsi in a Coke machine. That's just a violation.
But Dr. Pepper, yeah.
Okay, we could, yeah, Dr. Pepper is important. Okay, well, I am a huge fan of root beer, so we're going to have root beer in this machine. Okay, we have root beer. Okay, you want sweet tea?
Yeah.
Brisk. Do you want brisk?
No, I don't like brisk.
Okay, I don't either. Okay, let's just do tea. Let's do sweet tea because we are from the South. Okay, well, I really like root beer, so I want another whole button for root beer. I want double root beer coming out of this machine. Okay, and what should be the last thing in our machine?
Sprite. Oh my
God. How about Sprite?
I messed something up somewhere and I don't know where.
It's okay. I know, but you know what? There has to be a little bit of something for every. You know what you're missing in this Coke machine? Something diet. But it's okay. Those people can, I don't know, they can go to a different machine. Okay, so this machine is functioning. And let me tell you why. Because this machine is predictable. I don't know what's going on inside the machine, but I know that if I hit the 1 button, I'm going to get a Coke. I know if I hit the 2 button, I'm going to get Dr. Pepper. I know if I hit the 3, I'm going to get a root beer. I know if I hit the 4, I'm going to get sweet tea. I know if I hit 5, I'm going to get a root beer. I know if I hit 6, I'm going to get Sprite. I know exactly what's going to happen if I hit any of these buttons. There's only one possible thing that could happen, okay? So my functions are predictable, okay? Functions are predictable. Relations could be a function, but they don't have to be. But functions are like a special type of relation, and they have to be predictable. So let me show you what that means. We got that written down? There you go. You're okay.
I have to rewrite it.
Okay, well, you're going to have to copy it. Okay, so now let's do our not functioning machine. So we're going to make a smaller bubble because this machine's only going to have 3 buttons. And then we're going to have a big bubble over here. Okay? So we're going to have 3 buttons in here. Button 1, button 2, and button 3. Okay? Now, I'll go ahead and get that written down. Now in this Coke machine, just like in the other one, if I hit the 1 button, I get a Coke. If I hit the 2 button, I get Dr. Pepper. If I hit the 3 button, I get root beer. Or sweet tea. Or Sprite. Or green beans.
Green beans?
It's canned. It could come out of the machine.
No. Well, no, it's heavy. Really.
That's okay.
Which?
Or
Oh no. I like green beans.
can of Pringles. Or an angry weasel. Okay, so button 1, totally predictable. Button 2, 100% predictable. But button 3 is pure chaos. I could get root beer, or sweet tea, or Sprite, or green beans, or Pringles, or an angry weasel could attack me. Like, I don't know what's going to happen when I hit this button, okay? Button 3 is not predictable, and that means this machine's not functioning. I think we've all, like, either had this happen to us or heard about it happening to us, where you put your money in the machine and you're like, okay, so like, for example, my husband's diabetic. So he gets diet drinks when he gets Cokes out of the Coke machine. So if he puts his money in and he asks for a Diet Dr. Pepper and he gets a Dr. Pepper, he has to basically, like, give it away because he can't drink that. Okay? So, like, everybody's had that thing where you put your money in the machine and you push the button and then something else comes out. You're like, this is not what I asked for, and you're kind of annoyed about it because the machine's not functioning. Okay? So in this case, button 3 is not predictable, and that makes this not a function. Okay? I could get a drink. I could have to drink green bean juice. I could get Pringles, don't have anything in them at all, or I could get attacked by a wild animal. Okay? I don't know what's going to happen, but only some of it's okay. Only one of those possibilities is what I want, which is root beer from that button. Okay? So when I look at this, the problem is that 1 and 2 are predictable, but 3 has all these possible outcomes. I don't know what's going to happen in the machine. I don't know what's going on in the machine, and I don't know how to guess what I'm going to get this time. Okay? I could get root beer 2 times in a row, and then all of a sudden the green beans come out. Like, I don't know what's going to happen. All right? So this machine is not functioning because it's not predictable. Okay? So, what questions can I answer about that part? We okay so far? Okay. So when I think about this machine, let's take it back to math, okay? So the first one over here, I had my button, right? That's my X bubble. The X button bubble is where the button is, okay? And the Y bubble is what I get when I press the button. Okay? So the X is the button, and Y is what I get when I press the button. And again, for this one, the buttons only have one option, so it's really predictable. I know exactly what's going to happen. But over here, the button is like predictable, crazy town, chaos. Like, I don't know what's going to happen, okay? So that's what we're talking about with a function, okay? So let's take a look over here, all right? Now, what we just did is called a mapping diagram, okay? And a mapping is a function when no X has more than one line coming off it. Okay? No X has more than one line coming off of it. Okay, so remember, This is my button here. I don't care what's happening inside the machine. I only care what's happening with the button. So if I look at this one and I cover up the machine, I don't care about the machine, and I just look at the buttons, are these buttons predictable? -4 only has one possibility. -1 has one possibility. 1 has one possibility. 3 has one possibility. This is predictable. That means this is a function. Okay? What about this one? Is this predictable? What's wrong with it? The 3 button has 2 possibilities. Okay? So right here, this 3 could go to a 4, or it could go to a -4. Now, on a test, I'm going to expect to see this documented. I'm going to expect you to show me why it wasn't a function. And if you don't, what do you think is going to happen? I'm going to mark it wrong, and I'm going to give you no points. Because I need to see your thinking, because y'all have had your chance. You've had your chance doing it your way, now you're going to do it mine. This is not a function. Now, our backup strategy all the time, this is always our backup strategy, is when in doubt, table it out. Okay, that is our backup strategy. So what does that mean? What does that mean? Let's talk about it. We put it in a table. I want you guys to watch. Pencils down. I want you to watch. I'm going to show you. Okay, so we literally make a table. Okay, and I map them out. So I take my -4 and it maps to 9. My -1 maps to -6. My 1 maps to -6. My 3 maps to 11. Okay, now, what do I care about? What am I looking for? I'm only looking at the X bubble. So literally, I'm going to squiggle out the Y's and just look at the X's. Do any of these repeat? No. Now, I've had some people ask me today, well, what about the 1 and the -1? Okay, they're not the same number. And here's how you can tell. Would you rather have $1 or owe $1? If you would rather one than the other, then they're not the same. If I said to you, would you rather have $1 or have $1? They're the same. They're the same. Like, it doesn't matter. But if there's one that you'd prefer over the other, then they are not the same. Okay? So, these are all different. That means this is a function. Now look at this one. Okay? When I draw this one. My 3 maps to 4. My 3 also maps to -4. So that means those are 2 different ordered pairs. I have 1 going to the 4, and then I have 3 also with the -4. I've got 5 with 0 and 6 with 2. I squiggle out the Y's. Now I had somebody last period say, well, why do I even write the Y's if I'm just going to squiggle it out? Because I need to make sure that I write every ordered pair. Okay, and I have to make sure that everything it maps up with, so every time I see a line, I'm drawing another ordered pair. Then we squiggle it out and we look, do I have anything repeated? Yep, right there, those 3's repeat, and that's why this is not a function. Okay, because for a table, no X values repeat next to the table. Okay? What questions can I answer so far? Okay, I want you to copy this down, and then I want you to try those 2 tables for me. All right, so for this one, now I had a good question, I don't remember which class, but I had a really good question. Somebody said, well, what if they're not right next to each other? Because like every example we've done, the 2 X values have been right next to each other, the 2 repeat X values. It doesn't matter if they're right next to each other. This is from your homework, so see right here, it doesn't matter if they're right next to each other. If you see the same Y value, the same X value twice, it's not a function. They don't have to be right next to each other. They just have to be in the same X list. Okay? All right, what other questions can I answer so far? Are we feeling okay about this? Yes, ma'am.
So if there's more Y values than X values, it can't be a function, right?
Not necessarily. Because it's possible that you could have the question was, is if there's more Y values than X values, it can't be a function. Because theoretically, I could have also had 5 go to, I could have had 5 go to 2, and then I would, and then 6 go to 4. Let me see if I can find an example for you. I could have had this. See, I could have had it like that. See what I'm saying? So it's not clear. But yes, in general, if there's more x's than y's, it's kind of got to be a function if there's more x's than y's. It's got to not be a function because how else am I going to, you know what I'm saying? Well, I mean, I don't know. I don't know. That's a great observation. That is a great observation because, yeah, you're pretty much right because I don't know. I don't even know anymore. Let's make a table. Just listen to things. Okay, all right, whatever. Okay, so I've just confused myself. Okay, so I'm going to show you 2 strategies for graphs. I don't even know anymore. I don't know anymore. Okay, so the first thing I'm going to tell you about graphs, okay, is for graphs we want no stacked x values, and the way we can tell that is with the vertical line test. Okay, I'm going to show you another strategy, a highlighter strategy that works really well. I will tell you this: no matter what you do, you need to use a highlighter when you're doing figuring out whether a graph is a function. You need to use a highlighter. Okay, so I want you to watch this strategy, and then in a minute I'm going to show you on the homework how to use the vertical line test. But this is a strategy. This strategy works with dots. So this is like the dot strategy. Okay, so just watch. Everybody, pencils down and watch. Okay, so I'm going to make a vertical line through every single dot. Okay, how many dots do I have?
5.
How many lines do I have? 5 lines. This is a function because I have the same number of dots as I do lines. Okay, now let's look at this one. How many dots do I have now? 1, 2, 3, 4, 5, 6, 7 dots. And I have 5 lines. Not a function. Now, if you don't want to do the dot and line strategy, you don't want to, then what you can see also, though, is you can see that right here, I have 2 x values stacked up, 2 values stacked on the same x. And right here, if you circle the values that are stacked up, that also counts for me as work. Okay? What do we think about this strategy? Seem pretty easy?
Yep.
Okay, now let me show you on your homework. First of all, let's go ahead and cross off number 7. Number 7 is number 7 is confusing a lot of people, so I don't want it to get in the way of us understanding this concept, huh? It's not hard. It is a function. It is a function, but I don't want us to worry about it. Okay, so let's look at these. First of all, when you'd use the vertical line test to decide if something is a function, okay, what you're going to do is always highlight the graph. Now, the reason I say this is because a lot of people like, so the vertical line test, by the way, is I take my line, I hold it vertically, and I look to see if it touches the line in more than one place. Here's the problem. People start to get confused because like right here, 1, 2, 3, 4, 5, 6 lines touching. Because there's the grid in the back starts to confuse people because there's a lot. So if we highlight the line that we're actually trying to see if it's a function, now instead of looking at lines, I'm looking at highlighter. Now I'm going to look at one side of my pencil. I mean, not both sides, one side. So I like to look at the left side. And then I move my vertical line to the right. And I look, does it ever touch the highlighter twice at the same time? Now, some people are like, what does that mean? So let me show you what a not a function looks like so you can understand that. So I highlighted the circle. Now look, does it touch the highlighter? See, right here, it's touching the highlighter twice at the same time. So this is not a function. But on this one, if you look, as I move my highlighter, is it touching the highlighter more than once at the same time? No. So this one is a function. Okay, now, is this a relation? Is it a relation? Why is it a relation?
Yes, it is.
Because if you can graph it, it's a relation.
Yes.
Is that a relation? Can you graph it?
Yeah.
Then it's a relation. This is a relation, that's a relation, that's a relation, that's a relation. Everything here is a relation because I can graph it. Function, though, is does it touch in the same place twice? Okay? So the last thing I want to look at here is these ordered pairs. Okay, now for the ordered pairs, what are we going to do, you think? We're going to table it. Now, in the past, when we've done these ordered pairs, okay, in the past I've tried a lot of strategies, but ultimately what it comes down to is when you look at ordered pairs like this, they're visually like really confusing because there's a bajillion commas and like 85,000 parentheses, okay? So we need to get rid of all that extra visual noise, okay? So we're going to plot them. So it's -6, 8, 3, 1, 2, 18, 4, 7. Now what do I do? Now that I have them in a table, what do I do? I squiggle out the y's. Do I have any repeated x's?
No.
This is a function. Okay, now I look over here. I do the same thing. -3, 0, 2, 1, 2, 4, 6, 5. And then I squiggle out the y's. Do I have any repeated x's?
Yes.
Yep, circle them so I know what they were. And now you know that this is not a function. Now I want to talk briefly about one more thing. Okay, so let's look at this problem here. On tonight's homework, I want you to do mapping diagrams on these 3 problems. The reason for that is on Friday when we come back and do domain and range, we're going to do the mapping diagram. So I want to show you with this problem how to make this into a mapping diagram. Okay? So everybody watch. You're going to do mapping diagrams on these 3, and I don't really care. You just tell me if they're functions after that. Okay? So for this one, what I'm going to do is I'm going to start, and I have messed this up every period, except last period is the first period I completely got it right, because I'm really bad at points. Anyway, whatever. Okay, so this first one is -2, 0. Remember, this is my x and this is my y. I just pick that one. It doesn't matter. I usually go from left to right. And then down here I've got -2, -3. So I don't write -2 again. No, I don't. In bubbles, in these mapping diagrams, I don't repeat a number. I just draw another arrow. Okay? Now over here I've got -1, 1. I've got 0, -2, and then I've got 1, 1. Okay, do you see that? All I did was I drew, again, I never repeated a number. So this -2 I didn't repeat and the 1 I didn't repeat, even though it appeared twice. Now, this is not a function. Is it not a function because of the -2 or because of the 1? Because of the -2. Because remember, I don't care what's going on inside the machine. I only care about whether the button is predictable. Okay? All right, so that's all I got for you.